Today we will be learning how to simplify algebraic expressions. We've done this a little bit before, but it's going to get a little bit more in depth right now. In other words, we are going to learn how to combine like terms. So some of you may have done this previously. I just want to get everybody on the same page. So I am going to share my screen with you. And we are going to do this. Okay, so simplifying algebraic expressions. Like I said, it's another word for combining like terms. First, we need to understand the distributive property. So if we have the expression 2 times in parentheses 4 plus 5, we can distribute this 2 inside of the parentheses. So we can get 2 times 4 plus 2 times 5. I think we can all agree that that's how the distributive property works. Now, what happens if we want to go in reverse? So say we're starting with what we ended up with above, 2 times 4 plus 2 times 5. I can pull out the common factor and turn it into a multiplication problem. So I can pull that 2 out and then have what's left, 4 plus 5. Okay. So this is going forwards with the distributive property. This is going in reverse. Now say we have this expression, 4x plus 5x. We are going to use the distributive property in reverse. So we're going to pull out the common factor, which in this case is x. And it's going to leave some parentheses with some addition. So what I'm going to do is I am going to pull out the x. And with variables, we tend to put the x, it's customary to put the x on the right side. So we're going to pull that x out, and we're going to be left with 4 plus 5. Okay, 4 plus 5 in parentheses times x. And we can simplify that. 4 plus 5 is 9 times x. Okay, another way to look at that to prove that it's exactly right, that this 4x plus 5x equals 9x. What if I listed all my x's out? Here I have 4 x's, 1, 2, 3, 4. And then I have 1, 2, 3, 4, 5. So I have a total of 9 x's. And that's just kind of a more graphic way of looking at it. Okay. Something to remember, if a variable is standing alone, it has a coefficient of 1. So in this case, 6y plus y, we assume, we understand that there is a 1 right there, even though it is not written there. So 6y plus 1y. And if we do the reverse distributive property, we get 6 plus 1 in parentheses times y, which is 7y. Okay. So you can see by just these couple of examples, we group together like terms, meaning if they have the same variable, we can group them together and do this distributive property. Okay. So if we look at this, 7x plus 2x, they're both in terms of x, both have the x variable. So we can simply add the coefficients. So 7 plus 2 is 9, and we still keep the x. Now, we have some powers, some exponents here. We have 5m to the second minus 2m plus 8 minus 3m squared plus 6. Lots of stuff going on. So what we're going to do is determine what our like terms are. So anything that has the same variable and the same power. So here we have a term that has an m squared, 5m squared, and here we have another one with m squared. Now we are going to keep this minus sign. This is going to become a negative sign eventually. So now we are going to combine these two We have a minus 2m here. We don't have anything else to combine with it. But then we have an 8 and a 6 over here. Okay, so now let's start combining. 5m squared minus 3m squared. 5 minus 3 is 2, and we keep the m squared. We only have one of the m's, minus 2m. Then we have plus 8 plus 6, which makes it plus 14. So this is our simplified expression. Let's do one more. This one has two different variables in it. So we can only combine the terms that have the same variables, the same letter name. So we have a k and a 4k. We can combine those. They have the same letters, same power. Here we have a 3n plus 3n, and then a minus 2n squared, I should say. Minus plus 3n squared minus 2n squared. So let's start combining. So the k and the 4k, remember when the variable is by itself, we assume that there is a number 1 right there. It is just understood. 1k plus 4k is 5k. And then we have a 3n squared minus a 2n squared. 3 minus 2 is 1. So we can write 1 minus 1 n squared. Oops, actually that's a plus 1. Okay. 3 minus 2 is 1. And we don't really need that. Remember, it's assumed that it's a 1. So we can write this super simplified as 5k plus n squared. So now go and practice some of those on your set of practice problems.